I'm going to show you how to bring this Vizio TV back from the dead. I'm powering up the TV right now, and we should be seeing a standby light at the bottom left corner, but we're not seeing anything. So let's open it up and find out why. Now that we have the back cover removed, we can see there's only a few circuit boards in the TV. We have our power supply, our main board, and our T-Con board down there. Our two main suspects are going to be the power supply and the main board. First, let's do a visual inspection on that power supply. So most often there aren't any obvious signs of a problem, but over here we can see there's actually a little bit of burning. It might be hard to see on camera, but there is a component that looks burnt. Now, if you don't have any obvious signs of damaged components on your board like we do, you're going to want to do a live voltage check with your multimeter. I am going to show you how to safely do a live voltage check with your multimeter in case you don't have any obvious signs of burnt components like we do. I'm going to put my negative lead on chassis ground, and we're going to use the positive lead to do our voltage measurements. I'm going to be checking the 19 volt lines, which are pins 3, 4, 5, and 6, and we're going to be measuring from the wired side. A lot of people will tend to try to use the exposed metal pins over here to do a measurement, but it's easy to slip and short out ground to a voltage line or a data line to ground. So always do it from the wired side. So this is pin 3 over here, and now I'm going to go ahead and turn on our TV. And unfortunately, we are getting 0 volts, which does confirm that our power supply is defective. Now that we've confirmed that the power supply is defective, let's remove it from the TV. If you found the video helpful so far, make sure to hit that like button and keep watching to find out exactly how we fix this power supply on a component level. I wanted to start by showing you the damage I was showing you earlier over here. And to give you a good idea, this is where it is on the board. So looking at it under the microscope, it's a lot more clear that we have some damage over here. Most likely came from the Q9100, which is this transistor right here. Another component that's obviously damaged under the microscope is this capacitor is burnt right here. Now this capacitor, C9100, is also in parallel with this capacitor over here, C9801. So we're gonna go ahead and replace both of those. Let's just do a quick check, starting with the outer pins to one another, and we're in resistance mode. I'm getting about 1.4 ohms, which is very low. That's what I consider a short. I believe for this transistor, we should be seeing about 10 kilo ohms. Let's measure the middle pin to the outer, 0.73 kilo ohms. That's very low. And then 0.74 on the other pin. One of the things I commonly see is R9111, which is this big resistor here. I believe it's supposed to be a little bit less than half an ohm. And let's check it. And it's 48 kilo ohms, rising 57, 300 kilo ohms. Right, so if that one is supposed to be shorted and we have extremely high resistance, which means that the resistor is damaged, burnt up inside, so that will also need to be replaced. And this is the back side of where our capacitor C9100 is, so let's go ahead and desolder it. All right, and now we should be able to pull it through. There we go. Now we'll do the same with C9801. And there we go. I've just put my new capacitors in, so we'll go ahead and solder them down now. We'll cut off the excess. We'll go ahead and do the resistor next. Same process. And it looks like we still have a little bit of solder in there. There we go. This one's got a little bit thicker leg, so it's harder to pull through. There we go. Yep, so actually it looks like the resistor on the bottom side, we couldn't see it before, but that's the actual component that burnt, and it was causing that black mark on the front. Right, and now that the resistor is removed, it's a little bit more obvious and clear that it came from that resistor. I am gonna go ahead and clean that up real quick before we go ahead and put the new resistor in. All right, so the reason we're cleaning this up is because I have heard that the burnt residue can be conductive sometimes, so we definitely want to clean it up to avoid that. Feed our new one through. All right, and finally we're going to do the transistor. So the reason I disconnect it from the heatsink first is because the heatsink will actually pull away some of the heat from my iron, and it'll make it just easier for me to desolder if it's not connected to that heatsink. And let's see if I can just push it through from the top. Or from the bottom, I guess. Oh. And now it comes off. Now that we have the transistor out of circuit, let's do one more check. And we are still getting our short of 1.4 ohms. On the new replacement transistor, we are getting OL, which means it's open loop, infinite amount of resistance, or at least too high for the resistor or for the multimeter to detect. And then if I have my left pin on the middle, the negative, we get 6.3 mega ohms, so millions of ohms, and that's what we're expecting. Before I install it, I am going to remove the old thermal paste, and we're going to put fresh thermal paste on there. Let's go ahead and do a little cleanup. We have a lot of joints with lots of flux. So I'm doing a first cleanup with a Q-tip, try to soak up as much of that extra flux as I can. And then the rest we'll clean off with a toothbrush. All right, now let's go ahead and do a quick recheck. We had an open resistor. We should have a short now. Okay, and we do. Let's go ahead and check our transistor. Do we still have a short on the outer pins? We're getting 9.8 kilo ohm, which is actually what we're looking for because there's a resistor in line with those two pins, and that is a 10 kilo ohm resistor, I believe. And then finally, middle pin to the outer pins. We also want to make sure we don't have a short. It's showing about 24 kilo ohms, which I think is a little low, but the reason that might be is because we actually have more damage I haven't shown you yet. If we flip the board over to the back, we're going to want to pay attention to this resistor right here. If we zoom in on it, we can tell it looks quite burnt. We can't even read what it says on it anymore. On the one to the right, we can see it says 10RO, but there's also right here at the tip of multimeter lead, there's a little bit of a burn mark. So this 10RO resistor is supposed to be, I think, 10 ohms. Let's go ahead and take a peek. And it's showing open. It's not even able to get a reading. This is supposed to be an 82 ohm resistor. And we're getting kilo ohms, so that's much too high. And this diode down here, D55UN-E1 is often shorted, but it does not look like that's the case this time around, which we're still going to replace it anyways because it is very common for it to short out. So in case it got damaged in a way that I can't detect right now, we're going to replace it. Finally, we have resistor 39103 over here. Same thing. This one's a 400 or 47 ohm resistor. The 4 here has a little bit of a burn mark, and that means it multimeter just turned off. Okay. And again, this one is 5.8 kilo ohms, which is much too high, so we're gonna have to replace that one as well. The last thing we're gonna do is also replace U9101 right here, and that's because it also commonly fails. So there's a lot of components on this power supply that do fail. If you wanna try and do this repair yourself and follow along with the video, I will have a component repair kit available in the description below, as well as a complete mail-in repair service where we'll do this repair for you. I'm gonna go ahead and start with the easy ones. We're gonna do the resistors first. Okay, let's go ahead and remeasure it now that we have our replacements. Oh, and sorry, so it is 470 ohms, not 47. All right, let's go ahead and check after install. And we're getting 81.3 and 10 ohms down here now. And we're getting that. Let's do a recheck on our D9103 now that we've replaced those resistors. And now we're actually detecting what looks to be a short, but it's 91 ohms, which is simply just these two resistors added together. So it's not actually a short. But like I said, let's go ahead and replace it anyways. And finally, the last part we're going to replace is the U9101 IC chip. And for that one, we're going to be using our hot air station. And I'm also going to be adding a little bit of flux to it to make it a little easier. So that does complete the repair of the power supply. Before we do bring it back to the TV, let's go ahead and do a quick little life check. Let's go ahead and plug it in and hope that nothing pops and explodes. Nothing popped or exploded. So at this moment, I'm gonna do a check on our 19 volts, which was pin 3456. And it's a little tough because I don't have a great ground pin. And I'm doing the dangerous thing that I told you not to do, which is take the measurement to an exposed pin. So just be very careful if you're doing this. And we are getting 16.22 volts. It is negative 16.22 volts because I have my leads inverted, which is fine, but it's not the 19 we're looking for, and that's actually correct. The 16 volts is good. If you have any idea why that is, I've never gotten 19 volts off of these boards. It's always been 16, and typically that works just fine. If you know, let me know in the comments because I'd love to understand why that is. But now we can go ahead and live test it in the TV and make sure that the rest of the power supply is working as it should. All right, our power supply is back in the TV. So let's go ahead and power it up. Let's take a look at our standby lights. And it's very faint, but I do see it. It did pop up. And let's power it on. Okay, and it's back on. And there we go, we have picture. Now, there is a defective screen here. That's normal, this is just our test sets. So don't mind the screen distortion, but we do have power. The backlight's turning on, everything seems to be powering up. So that does confirm we have a successful repair. If you are interested, like I said earlier, to try and fix it yourself, we will have a repair kit linked in the description down below. But a fair warning, this is not an easy repair as you just saw. It is very advanced. So we will also have a mail-in repair service where you can send in your power supply. Again, that'll be in the description down below. If you liked the video, if you found it helpful or useful, leave us a like and subscribe. Thanks for watching.